The geometry of narrative, mapping structural forms. Hello, and welcome. Thank you for joining me today. I want to begin by asking you to think about a story you love. Maybe it's a film, a novel, or a video game. As you think about it, try to describe its journey. What words come to mind? Maybe you say it had a great flow or a twisting plot, or it felt like it came full circle. We use these spatial and geometric metaphors all the time, but what if we took them literally? What if we could use the language of geometry, lines, paths, branches, networks, and even three-dimensional forms to understand the very structure of a narrative? This is not a purely theoretical exercise. The need for a visual, geometric understanding of narrative is more pressing than ever. Traditional narrative forms, like a linear novel or a two-act play, are becoming just one of many options. We now have to contend with complex, multi-threaded television series, expansive transmedia universes, and video games where player choice fundamentally alters the story. How do we, as analysts, theorists, or creators, make sense of these complex systems? We need a new set of tools. We need a new way of seeing. Today, we're going to explore what I call narrative geometry, the concept of using geometric shapes and structures to map and analyze narrative forms. We'll look at some of the historical precedents for this idea, and then build up from the simplest models to the most complex, showing how this approach can give us a powerful new perspective on the stories we consume and create. The idea, as I mentioned, is not new. Think back to Freytag's pyramid, a diagram many of you likely encountered in your introductory literature courses. It maps the classic dramatic arc, a rising action, a climax, and a falling action. It's a simple, elegant geometric shape, a pyramid, that represents a universal structure. But it's just the beginning. The models we will discuss today go much deeper, offering far more analytical power than a simple triangle. Proppian linearity, the narrative path. Let's start at the beginning, with one of the foundational figures in the structural analysis of narrative, the Russian folklorist Vladimir Propp. In the 1920s, Propp undertook a monumental study of over 100 Russian folk tales. He didn't focus on what was unique about each story, but rather on what was universal. His astonishing finding was that, despite their different characters, settings, and conflicts, all these tales followed a rigid, sequential pattern. He identified 31 functions or key plot points, actions that drive the narrative forward, and argued that they always appear in the same order. For example, interdiction, or a command given to the hero, is always followed by violation. Villainy is always followed by departure. When we translate Propp's model into a geometric form, it gives us the most basic and fundamental narrative shape: a single directed line segment. Imagine a timeline, a vector. It has a clear starting point, what Propp called the initial situation or a state of lack, and a clear endpoint, the resolution. The journey along this line is the sequential progression of Propp's 31 functions. Each function is just another step, another segment along the path, moving the narrative inexorably from a problem to its solution. Let's use some classic examples to make this concrete. The story of Little Red Riding Hood. The initial situation is her home with her mother. The interdiction is her mother's command not to stray from the path. The violation is when she disobeys. The villainy is the wolf scheme. The departure is Red Riding Hood's journey into the woods. The struggle is her encounter with the wolf. And so on, down the line, until we reach the resolution with the woodsman's intervention and the defeat of the villain. This model is powerful because it reveals a clear, invariant structure. It's a very clean, very elegant way to diagram a story that is purely sequential. It's also an incredible tool for comparative analysis. We can take two seemingly different stories and lay them out on this Proppian line to see if they share a similar functional structure. Consider the first Star Wars film, A New Hope. Its narrative structure is remarkably Proppian. Like the Empire has stolen the Death Star plans and the princess is captured. Mediation. R2-D2 carries the plans and a message to Obi-Wan Kenobi. Departure. Luke Skywalker leaves his home planet of Tatooine. Donor. Obi-Wan gives Luke his father's lightsaber and teaches him the ways of the Force. Struggle. The climactic battle against the Death Star. Victory. Luke destroys the Death Star.
Resolution. The heroes are honored in a ceremony.
We can see the same linear progression in many Hollywood blockbusters, which often borrow from the hero's journey archetype. It's a very safe, effective, and well-understood narrative geometry. Think, too, of the structure of classic detective stories, like Arthur Conan Doyle's Sherlock Holmes tales. They follow a predictable linear path. A client presents a problem. Holmes takes the case. He follows a series of clues. There's a confrontation with the culprit and a final explanation of how he solved the mystery. This is a clear, step-by-step Proppian line. The lack is the unsolvable mystery. The resolution is its solution. But the limitations of this model are immediately obvious when you look at its geometric form. A straight line can't represent deviation, choice, or backtracking. What about a story where the hero tries something and fails, and has to go back and try a different approach? Or a story where a character has to make a choice between two equally compelling paths? Prop's model struggles to account for anything other than a single, predetermined one-way journey. It's a closed system. This brings us to our next geometric model, one that embraces the very concept of choice. Bremondian branching, the narrative tree. The French narratologist Claude Bremond was one of the first to offer a significant critique of Prop's rigid linear model. Bremond argued that narrative is not a fixed sequence, but a series of choices. For him, a story is a series of possibilities that are either actualized or not. He described a fundamental sequence of potentiality process result. A character is presented with a potentiality, a choice, and based on their action, a process unfolds, which leads to a result. Geometrically, this is no longer a line. This is a tree or a graph. The nodes are the decision points or the narrative states, a moment of choice. The edges are the paths or actions that are taken. A potentiality is simply the existence of multiple possible edges coming off a node. This model allows for far greater complexity and accurately maps narratives where agency and choice are central. We can diagram divergent paths where different choices lead to completely different outcomes. But we can also show convergent paths where different choices, different branches of the tree, can lead back to the same node or the same shared outcome. For example, a character can choose to be kind to a person or unkind, but both paths might eventually lead them to the same plot point, a critical piece of information. This concept is absolutely essential for understanding modern interactive media. To truly understand this, let's look at a concrete example. The video game Detroit: Become Human. The game is literally built as a Bremondian narrative graph. You, the player, are constantly at a node, making choices. Should I be peaceful or aggressive? Should I lie or tell the truth? Each choice is a branching path, an edge on the graph. The narrative's geometry is so complex that the game itself shows you, at the end of a chapter, the full decision tree you navigated. It's a perfect real-world visualization of Bremon's theory. We can see how the graph can explode in complexity, with hundreds of possible paths, and yet also converge at key points to bring a group of players back to a shared experience. This model is so powerful that it's often referred to as a state machine, a concept from computer science. Each node is a state of the narrative, and the edges are the transitions between states. Think of a narrative as a set of possible worlds. A state machine maps the paths between those worlds. We can also apply this to a more traditional medium. Choose Your Own Adventure books are the perfect example of a literary Bremondian tree. Each page is a node, and the Go to page 56 or Go to page 72 instruction is an edge leading to a new node. The narrative branches and diverges with every choice the reader makes. Even non-interactive narratives can be seen through this lens. Consider the film Run, Lola, Run. While the audience doesn't make the choices, the film explicitly shows the narrative branching off from a single starting point. Lola has a choice: how to get the money. The film plays out 3 different versions of her journey, each a different branch of a narrative tree. to show how small choices can lead to wildly different results. Bremon's model is a crucial leap forward because it acknowledges the possibility of multiple realities within a single narrative framework. It moves us from the certainty of a line to the contingency of a branching structure. Advanced geometric representations. The Proppian line and the Bremondian tree are powerful tools, but they still don't account for the full range of narrative possibilities. So, let's push our geometric thinking a bit further. Not all stories are purely linear or branching. What about stories with a recurring pattern? For a story with a recurring cycle, we can use a circular path. Think about the film Groundhog Day. The narrative geometry is a loop. The protagonist, Phil Connors, starts at a node, waking up on February 2nd, goes through a process, and ends right back at the same node, repeating the same day. For a cycle that is repeating but also escalating, where each repetition builds on the last, adding new information or complexity, we could use a spiral. Think of a show like Russian Doll, where each cycle starts the same, but the character's journey moves forward, adding a new layer to the narrative. What about stories with multiple protagonists? For this, we need multilinear diagrams. Imagine two or more parallel lines, each representing the journey of a different character or storyline. In a sprawling epic like Game of Thrones, we can map the journey of Daenerys Targaryen as one line and the journey of Jon Snow as another. These parallel lines might intersect at key plot points where the characters' stories converge or their decisions impact one another before they diverge again. This model is also perfect for ensemble cast films like Love Actually or Pulp Fiction, where multiple distinct storylines run in parallel and intersect in surprising ways. And what about an entire universe of stories? For that, we need to think in terms of a network graph. In this model, individual stories, films, or episodes can be represented as nodes. The edges between those nodes are the shared characters, events, or objects that link them. Think about the Marvel Cinematic Universe. Iron Man is a node, and so is Thor. The edge connecting them is Nick Fury's cameo in the end credits scene. The node for the Avengers is a central hub, as it connects all the previous individual hero nodes. This network diagram allows us to visualize the intricate web of connections and identify the most critical nodes in the entire narrative universe. We can also use this model for the shared world of Stephen King's novels, where stories are nodes and recurring characters, or places like Derry, Maine, act as the edges. Finally, some stories are so complex they defy a simple two-dimensional map. Think about a story with multiple nested levels of reality, like the film Inception. How would you diagram a story that operates on 3 different levels of consciousness at once? The dream within a dream within a dream. A simple 2D tree or line is insufficient. This kind of narrative might require a kind of 3D narrative space, where layers of narrative exist on different planes, linked by a character's journey up and down between them. It's an idea that pushes the boundaries of how we can possibly visualize a story. We can also see this in shows like Westworld, where narratives exist on multiple temporal layers that must be navigated to understand the full story. Benefits and limitations. So we have these powerful tools. What are they good for? What can they do for us that a close reading of the text cannot? First, they offer incredible clarity. A geometric diagram can make a complex, interwoven story much easier to understand. It simplifies the oral and textual experience into a visual one. We can see the forest and the trees. Second, they are incredible analytical tools. As an audience or a critic, we can use these maps to identify patterns, bottlenecks in the plot, or even redundant paths in a story. We can ask questions like, is this story's structure more like a river or more like a tangled web? And for creators, they are a powerful design tool. Before you start writing a complex story, you can use these geometric forms to map out your possibilities, to check for coherence, and to ensure you haven't created a dead end for your characters. But these tools are not without their limitations. The biggest risk is oversimplification. A map is not the territory. The emotional depth, the thematic nuance, the beauty of the prose, the subtle character development, None of that can be captured in a diagram. And as we've seen, mapping a very large or highly interactive narrative can quickly become too complex to be useful, looking more like a tangled mess than a clear geometric shape. Ultimately, the story itself still matters more than its diagram. A bad story with a great structure is still a bad story, but a great story with a powerful, elegant structure can be all the more impactful. These geometric models are not a replacement for good storytelling. They are a way to better understand its mechanics. They allow us to see the skeleton beneath the skin, the architectural blueprint of a world we can't physically inhabit. They are a way to find the hidden mathematics in the art of narrative. What kinds of stories do you think are best represented by a geometric model? Let me know in the comments below. Thank you for your time.